Okay, today let's quickly run through upthrust. So upthrust is defined as the buoyant force that acts on an object that are totally or partially immersed or submerged in a fluid. So the buoyant force acting on an object partially or totally immersed in a fluid. When they talk about fluid, we have gas or liquid. So now, this is as a result of the weight of the fluid displayed. Now, let's say we have a particular bowl here or a beaker. At first, if you have a spiral spring, and we weigh a particular mass of a substance in air, if the mass is around this region, let's say 50 or 5 Newton. If the mass is 5 Newton, by the time we dip it totally into a liquid, let's say water or any other liquid, there is going to be a difference in the mass, in the weight of the particular substance. It will reduce, let's say, to 4 Newton. That means there's a force that is acting on this object, an upward force, a buoyant force, and that force is what we call upthrust. Is working negative to the weight of the object. So we can say the upthrust of a soil is equals to loss in weight of a substance. And what's the loss in weight? When we recorded, this was in air, this is a weight in liquid, so weight in air. So we can say weight in air minus weight in the liquid. So this upthrust is also equals to the tension in the spring and also the spring balance. So there's what we have to understand. There's this man Archimedes. Archimedes talked about when a body is partially or totally immersed in a fluid, it experiences an upthrust, which is equal to the weight of the fluid it displaces, or to the weight of the fluid displaced. So Archimedes' principle states that a body when a body is partially or totally immersed in a fluid, as liquid or gas, it experiences an upthrust, which is equal to the weight of fluid displaced. So from Archimedes' principles, that means we can say that the upthrust is equals to the weight, and the weight is also equals to what? Mg. We have to note that. Now that is where the mass, m is the mass of this fluid displaced, the mass of fluid displaced, g is the acceleration due to gravity. Now we can also say that the upthrust is equals to the density times the volume times the acceleration due to gravity. How did they come about this? Recall that density is equals to mass over volume, the ratio of the mass to the volume. And we have mass here, so let's make mass the subject formula in this case. Therefore, our m equals to rho v. So putting rho v instead of m, that's how we come to this equation. So we can say U equals to rho Vg. So this is another equation we can use for upthrust. Now it's possible the solid is not totally immersed in a fluid. If it is partially immersed, maybe 1/3 or 2/3 of its volume was immersed, then we say that the upthrust is equals to the, let's say if it was 1/3, then we say 1/3 of the volume times rho g. So we can write that as 1/3 rho vg. If it is 2/3, we write 2/3 rho vg. Now let's look at how this. Remember that if we want to use the relative density of a liquid, we want to determine the relative density of a liquid using Archimedes principle. Now look at we have relative density, which equals to the upthrust in liquid over upthrust in water. Upthrust in liquid over upthrust in water, and we know this one is loss in weight. Loss in weight in liquid over loss in weight in water. So if we have loss in weight in air, so we can write it as W air, because loss in weight in the liquid is W air minus W in liquid over W air minus W in water. And we remember that W equals to mg, weight equals to mass times acceleration due to gravity. Then we can put it like this: mass in air times the acceleration due to gravity minus mass in liquid times acceleration due to gravity over mass in air times acceleration due to gravity minus mass in water times acceleration due to gravity. Let's bring out the g's. So we have mass in air minus mass in liquid over mass in air minus mass in water. Bringing out the g cancels each other. So therefore we can just say the relative density of the solid, the relative density of the liquid equals to mass in air minus mass in liquid over mass in air minus mass in water. Sure. So if we have that, so let's say, but we have relative density of a solid. For the liquid, we said is mass in air minus mass in liquid over mass in air minus mass in water. But for liquid, relative density of a solid, we write weight of the solid, weight of a solid over weight of equal volume of water. And so we can just write that as equals to weight of solid over upthrust in water. Upthrust in water is the mass in air minus, or weight in air minus weight in water. So that's the upthrust of the water. An example, let's look at this example that says that, for example now, an object of volume 4 meter cube, the volume is 4 meter cube, is totally immersed in a liquid of density, that's density of the liquid of density 103 kilogram per meter cube. Calculate the upthrust. So we are looking for the upthrust of the liquid on the object, given that g equals to 10 meter per seconds squared. Now we have the v, we have the rho, we have the we have the g, and we're looking for the upthrust. So since the density of the liquid has been given and the volume of the liquid displaced. This was the volume of the liquid displaced. How do they get this to be the volume of, they said an object of volume for, so the volume of the solid, volume of the object equals to volume of liquid displaced. This is according to Archimedes principle of thrust, that the Archimedes principle says that when a body is totally or partially immersed in a fluid, it experiences an upthrust which is equal to the volume of liquid displaced. That means the volume of the object that we are given is also equal to the volume of the liquid displaced, and that is also 4 meter cube. So since we have, and we have the upthrust in liquid equals to the density, the liquid density times the volume times G. So we can now write this as 1030 times 4 times 10, and this will give us 41,200 newtons. So the upthrust of in the liquid is equal to 41,200 newton. Now look, let's take a question where we need to use the a body. This is another example. A body weighs 0.30 newton in air. How do we write that? We write it weighs, that weight in air equals to 0.30 newton. 0.25 newton when fully immersed in water. When fully immersed in water, that means weight in water equals 0.25 newton. And 0.27 newton when fully immersed in a liquid. We write weight in the liquid equals to 0.27 newton. Calculate the relative density of the body. So we are looking for relative density of the body and relative density of the liquid. In this case, we remember that relative density equals to weight of the solid, weight of solid over weight of equal volume of water. And this we can also say is the same thing as weight of solid over upthrust in water. So what the upthrust in water, we remember that is loss in the weight of the water. We have been given the weight of the solid in air. That's weight of solid when it has not been immersed. That's the weight in air. So we can write weight in air over weight in air minus weight in water. Weight in air is 0.30 over 0.30 minus is 0.25, and this will give us 0.30 over 0.05, and that gives us 6. So to get the relative density of the liquid, we make use of what? If we are going to look over the relative density of the liquid, we have weight in air minus weight in liquid over weight in air minus weight in water. Weight in air is 0.30 minus 0.27 over 0.30 minus 0.25. So we have 0.03 over 0.05, and that's what. So 0.03 over 0.05, and this gives us 3 over 5, and that's 0.6. Relative density, remember, it does not have a unit, because this unit will cancel this, so it's unitless, is dimensionless. Now we have a question from NECO SSC, question 2004. And this question reads that a body has masses is 0.013, that is 0.013 kg, and 0.012 kg in oil and in water respectively. That means this is mass in oil and this is mass in water respectively. If the relative density of the oil equals 0.875, calculate the mass of the body, that's mass of the body itself, and that's the mass in air. We know that relative density of oil, RD of oil, is equals to mass in air minus mass in liquid over mass in air minus mass in water. Since we have been given these two, we have a 0 point, okay, mass in air is what we're looking for. Let's call it M. Mass in M equals to M. So let's say this is M minus, okay, let me bring it down. 0.875 equals to M minus mass in liquid, that's mass in oil. So M minus 0.013 over M minus 0.012. Then we cross multiply. This will give us 0.875 M minus, so we're going to multiply 0.875 times 0.012, and that will give us 0.0105, which equals to M minus 0.013. Let's take this M to this side. So I'll take this M, something smaller, bring it to this side and bring this. So we have 0.013 minus 0.0105, which equals to M minus 0.875 M. So then what is 0.013 minus 0.0105 gives us 0.0025, 0.0025, which equals to, we have bring out M, we have M equals to 1 minus 0.875. So, and this will give us 0.0025 equals to 1 minus 0.875 gives us 0.125 M. Divide both sides by 0.125, 0.125. This cancels out this. Therefore, M equals to 0.0025 divided by 0.125, and that is 0.02 kg. That means the mass of the oil in air equals to 0.02 kg. Flotation. So we see many objects are floating in water or in a particular liquid. So we need to know the principle. There's a principle we call the principle of flotation. And this principle states that an object will float in a fluid, that is in a liquid or gas, when the upthrust exerted upon it by the fluid is equals the weight of the object. When the upthrust exerted upon it by the fluid equals the weight of the object. That means that, or we can say alternatively, we can just say that a floating body displaces its own weight. So that means if U equals to the weight of the object, then we say that that body will surely float. Let's take an example from JAMB. This is JAMB, the JAMB question 1988, and it says that a body whose mass is 2 kg, a body whose mass is 2 kg and has a volume of 500 centimeter cube, V equals to 500 centimeter cube, just floats when completely immersed in a fluid, in a liquid. Calculate the density of the liquid. So we're looking for the liquid density. The density of the liquid is what we are looking for, and we know that this is centimeter cube. We can't leave it in that way. So let's calculate the weight. Weight equals to mg, which is 2 times 10, which is 20 Newton. So we have calculated the weight. We also have the volume, which is 500 centimeter cube. So we need to convert it to meter cube. And how do we convert it to meter cube? 500 centi means 10 raised per minus 2 meters. So then multiply by 3, that's raised per 3. So we can write this as 500 times 10 raised per minus 6 meter cube. Or we can say V equals to 5 times 10 raised per minus 4 meter cube. So this so now from using upthrust, we know upthrust is rho Vg. So this is the formula for rho Vg. So we need to now use the law of flotation. So from the principle of flotation, that means that W equals to the density, no, equals to the upthrust. Sorry, W equals to the upthrust. So in this case, what's W? W is 20 Newton. We write 20 Newton. Let's write 20 Newton equals to upthrust is rho Vg. So what's our rho? Our rho is what we're looking for. We are looking for the density of the liquid, and so times the V is 5 times 10 raised per minus 4 times 10. So liquid, density of the liquid equals to 20 over 5 times 10 raised per minus 4 times 10. This here 1, this here 2. So we have 2 over 5 times 10 raised per 4. And that gives us this 0.4 times 10 raised per 4. And that we can write it as 4 times 10 raised per 3 kilogram per meter cube, or 4,000 kilogram per meter cube. So this is just the concept of flotation.